Welcome to my channel. Please subscribe. MQTT. MQTT, Message Queuing Telemetry Transport, is a lightweight messaging protocol that is widely used in the Internet of Things (IoT) applications. It was developed in 1999 by IBM and has since become a popular choice for IoT communication due to its efficiency, low power consumption, and support for unreliable network connections. MQTT uses a publish-subscribe model for message exchange, where messages are published to a broker and then delivered to all subscribed clients. This makes it a great choice for IoT applications where low bandwidth and intermittent connectivity are a concern. One of the major advantages of using MQTT in IoT applications is its support for low-power devices. MQTT was designed to be lightweight and efficient, making it ideal for small IoT devices with limited processing power and memory. Another advantage of MQTT is its ability to handle unreliable network connections. Since MQTT uses a publish-subscribe model, messages are buffered at the broker until the subscriber is available to receive them. This means that even if a device goes offline for a short time, it can still receive all the messages that were sent to it when it comes back online. MQTT has several use cases in the IoT domain. For example, it can be used to collect sensor data from remote devices, such as temperature, humidity, and pressure readings. This data can then be analyzed and processed in real time to derive insights that can be used to optimize various operations. MQTT can also be used to control IoT devices remotely, such as turning on/off lights, adjusting thermostats, or opening/closing doors. Additionally, MQTT can be used to monitor the status of IoT devices and alert users if there is any issue, such as low battery or connectivity problems. To use MQTT in an IoT application, there are several components that need to be in place. First, there is a broker that acts as a message hub, receiving messages from publishers and delivering them to subscribers. Second, there are the publishers, which are the IoT devices that generate messages. Finally, there are the subscribers, which are the applications or services that receive the messages and take appropriate actions based on the content of the messages. Together, these components form an MQTT network that can be used for a wide range of IoT applications. Overall, MQTT is a powerful messaging protocol that can be used in a wide range of IoT applications. Its lightweight and efficient design make it ideal for low-power IoT devices with limited processing power and memory, and its support for unreliable network connections makes it a great choice for IoT applications that require robust and fault-tolerant communication. By leveraging MQTT, IoT developers can build highly scalable and reliable applications that can deliver real-time insights and enable new levels of automation and control. MQTT methods and components. MQTT, Message Queuing Telemetry Transport, is a lightweight messaging protocol designed for IoT devices with limited processing power and bandwidth. It is a client-server architecture that uses publish-subscribe messaging to provide efficient and reliable communication between devices. MQTT protocol operates on top of TCP/IP and is widely used in IoT applications for its simplicity, scalability, and reliability. MQTT protocol defines two main components, MQTT client and MQTT broker. The MQTT client is an application that sends or receives data using the MQTT protocol. It can be a device or a software application running on a device. The MQTT broker is the central hub that receives messages from the MQTT clients and forwards them to the appropriate destination. It is responsible for managing topics, subscribers, and messages. MQTT protocol supports three types of message transmission: publish, subscribe, and unsubscribe. The publish message is used by an MQTT client to send a message to the MQTT broker. The subscribe message is used by an MQTT client to subscribe to a specific topic on the MQTT broker. The unsubscribe message is used to unsubscribe from a previously subscribed topic. MQTT protocol also supports two quality of service, COS, levels, COS 0 and COS 1. COS 0 provides a best effort delivery mechanism where messages are delivered at most once. COS 1 provides an assurance of message delivery where messages are delivered at least once. It is up to the client to decide which COS level to use for message transmission. In addition to the core MQTT protocol, several other methods and extensions are available for MQTT. Some of the commonly used methods are last will and testament, LWT, retained messages, and session persistence. The LWT mechanism is used to notify subscribers of a client's unexpected disconnection. Retained messages are used to store and deliver the last message published on a specific topic. Session persistence allows a client to reconnect to the MQTT broker and resume the session with the same state as before disconnection. MQTT communication. MQTT, Message Queuing Telemetry Transport, is a lightweight publish-subscribe messaging protocol designed for machine-to-machine, M2M, and IoT applications. MQTT follows the publish-subscribe model, where publishers send messages to a broker, which then delivers them to all subscribers interested in those messages. The MQTT protocol uses TCP/IP as the underlying transport protocol and works on top of the MQTT broker. MQTT communication starts with a client sending a connect packet to the broker to initiate the connection. Once connected, the client can then subscribe to one or more topics by sending a subscribe packet to the broker. The broker then sends the client a subback packet to confirm the subscription. When a publisher publishes a message to a topic, the broker receives the message and then sends it to all subscribed clients by sending a published packet to them. The client can also send messages to the broker by sending a published packet with the topic and message. MQTT also supports quality of service, COS, levels to ensure message delivery. COS level 0 guarantees at most once delivery, where the message is delivered once and the broker doesn't keep track of the delivery status. COS level 1 guarantees at least once delivery, where the broker ensures that the message is delivered to the subscriber at least once. COS level 2 guarantees exactly once delivery, where the broker ensures that the message is delivered to the subscriber exactly once, eliminating any duplicates. MQTT components include clients, brokers, and topics. Clients are devices that can connect to a broker to publish or subscribe to topics. Brokers are message brokers that receive messages from publishers and deliver them to subscribers. Topics are logical channels that clients can subscribe to, and messages are published to. Overall, MQTT is a simple, lightweight, and efficient protocol for IoT applications that require reliable and efficient communication between devices. Its support for COS levels and publish-subscribe model make it ideal for IoT scenarios where low bandwidth and high scalability are important factors. MQTT topics and applications. MQTT, Message Queuing Telemetry Transport, is a lightweight messaging protocol used in the Internet of Things, IoT, to exchange messages between devices. The protocol allows devices to communicate with each other even in low bandwidth and unreliable network conditions. MQTT uses a publish-subscribe model in which a publisher sends a message to a specific topic, and all subscribers subscribed to that topic receive the message. In MQTT, topics are hierarchical and are represented using a /separated string. For example, a topic for temperature sensor data might be represented as sensor's temperature. Topics can have one or more subscribers, and a subscriber can subscribe to one or more topics. MQTT allows for wildcard subscriptions, which can be used to subscribe to multiple topics using a single subscription. For example, Sensors Plus would subscribe to all topics under the sensors hierarchy. MQTT has many applications in the IoT, including remote monitoring, home automation, and industrial automation. For example, a temperature sensor in a smart home might publish temperature data to an MQTT broker, which is then subscribed to by a home automation controller that adjusts the temperature based on the data received. In industrial automation, an MQTT-enabled sensor might publish data on the status of a machine, which is then subscribed to by a controller that initiates maintenance or repair based on the data received.